back, 8th graders. It's Mrs. Thompson, and we're still in 4.9. We're going to do example 3 right now, and I want to challenge you with a little bonus question. So right up underneath here and write bonus, and I want you to tell me what kinds of lines have the same slope but different y-intercepts. What kinds of lines, I'll say it again, what kinds of lines have the same exact slope but different y-intercepts? I'll give you a second, pause me so you can think and write your answer down. Okay, we're going to get started today with perpendicular lines. Perpendicular lines are lines that intersect and they form 90-degree right angles, okay? If you have two non-vertical lines that are perpendicular, that only occurs mathematically if the product, if you multiply their slopes together and the slopes equal 1, negative 1 after you multiply them together, then you know you have perpendicular lines. Now, vertical lines are always perpendicular horizontal lines. You don't have to think about it. There's nothing to calculate here. Just remember, vertical lines, no slope, are always perpendicular horizontal lines that have a 0 slope, okay? Undefined slope is always perpendicular to a slope equal to 0. So I just want to make sure you memorize that, okay? And that you firmly have that entrenched in your mind, okay? Now on your notes, you probably on the right-hand side, somewhere in this area, you had a graph. I actually took mine off. I'm not going to graph these lines. I'm not going to waste my time graphing them. I just want to study the numbers. That's it for each of these. So let's start right here with x equals negative 2. Special line. You know why I know it's special? Yep, because there's no y term. Now what kinds of lines have no y term, which means they never cross the y-axis? What kind of line is that never crosses the y-axis? If you said, hey, that's a vertical line, you're exactly right. So that's going to be a vertical line running through negative 2 on the x. What that means is no matter what y is, x is always going to be negative 2. So that's a vertical line. Okay, there's another special line. You know why I know it's special? Yep, you guessed it. There's no x term. What kinds of lines have no x term? And if you said horizontal, you're exactly right. Horizontal lines, beautiful. So remember, vertical lines have a slope that is undefined. And horizontal lines have a slope equal to 0. That means these two equations are perpendicular to each other. And so I'll show you the symbol that we use in geometry. We say x equals negative 2. This is the symbol we use. It's perpendicular. It's an upside down capital T. It looks like a vertical line hitting a horizontal line at a 90-degree angle. That's what it looks like to me, at least. And so that's how we show that, yes, those are perpendicular. Okay? So that's going on this bottom part that I showed you earlier. Vertical lines are always perpendicular to horizontal lines. Mathematically, I can't really show you how they equal negative 1. But I can tell you that if you have a vertical line and a horizontal line crisscrossing, they are perpendicular beyond a shadow of a doubt. Okay, let's focus on these last two right here, okay? Because they are not special. They have their x term, they have their y terms. They're just regular run-of-the-mill equations. Now our first one is y equals negative 4x. So clearly you can see that the slope is equal to negative 4. That's in slope-intercept form. There's no number back here, but it's understood to be plus 0. So if you want to know what the y-intercept is, you don't need it for perpendicular lines like you do parallel lines, but that's what it is if you were wondering. Okay, now let me erase this and we'll get back on track. The second one is in point slope form, and that gives us some information that we need. I don't really need to know anything but the slope, and here it is. M is 1/4. So numerically, if we follow what the instructions say, because it says two non-vertical lines are perpendicular if and only if the product of their slopes is -1. Well, product is multiplication. So if I multiply these slopes together, they are perpendicular if they equal -1 when I multiply. So let's take a look. We have -4/1 times 1/4. -4 times 1 is -4. 1 times 4 is 4, and -4 divided by +4 is -1. Yes, these lines are perpendicular, so we can say that is true about these two as well. Do the upside down capital T, and we can say these lines beyond a shadow of a doubt are perpendicular. Now, another way that I have taught it in previous years, I have told my students, you know, if the slopes are opposite reciprocals of each other, then that means they are perpendicular. So opposite just means one of them is negative, the other one is positive. That's all that means. Opposite just refers to the sign. And then reciprocals is basically one of them flipped over. So let's take a look. I do need to clear a little bit of board space, so I'm going to erase right here. You don't erase, just let me erase. And you keep writing down your page. And here are the two slopes we're comparing. Okay? So first of all, do you see that they are opposite? Do you see that one of them is negative and the other one is positive? Okay, hopefully you do. Okay, -4 is negative, 1/4 is positive, so they are opposite. So we got that part of it. Are they reciprocals? Is 4/1 the reciprocal of 1/4? Yes, they are. So there's two ways to tell if they are perpendicular. First of all, you can look to see if they are opposite reciprocals of each other, or if you calculate the product of their slopes and get it equal to -1, then you know also that that is true, that they also must be perpendicular. Okay, that's the end of example 3. If you have any questions, please bring them to class.